Hello, everyone, and welcome to another mini sky tonight. So in previous videos I've done, I talked about some of the different moons around different planets, including our own and Mars. So if you want to check out the video of the moons of Mars, Phobos and Deimos, I did a video of that, and I'll leave a link right up here, and you can check out Phobos and Deimos around the planet Mars. But today I want to discuss about 4 of the moons of Jupiter, which are the Galilean moons, and their unique features and why some scientists are interested in them. So let's check them out. So just some basic information. They were named after the quote-unquote loves of Jupiter, and I won't get into further details on it. There's a whole Greek and Roman mythology about them. But Io, Europa, Ganymede, and Callisto were people of great interest to Jupiter or Zeus in this particular matter, and he was very fond of them. And we'll leave it at that. I want to try to keep it as PG as possible. But the first recorded observations of these particular moons was done by Galileo Galilei in January of 1610. In fact, in this image right here is his first recordings of tracking the Galilean moons. But Galileo named the moons as Jupiter 1, Jupiter 2, Jupiter 3, Jupiter 4, just to keep consistent, as you can kind of see in his drawings right there, because he just wanted to keep them consistent. The names, however, came from Simon Marius, who wanted to keep with the traditional Greek and Roman tradition and named them after the love interests of Jupiter, since they would go around Jupiter. So let's go over some of the basic information of each of these individual moons. First one, Io, which is the closest planet towards Jupiter. Its orbit lasts 1.8 days, so it goes relatively fast around such a large planet, but it's still relatively far away from the planet, so it doesn't get sucked in. But since it's so small, it has to travel so fast around the planet, or else it will get sucked in. It's tidally locked, meaning one side of the moon always faces Jupiter at all times. And so sometimes that one side of Io is what usually be the most volcanic. And indeed, it's called a volcanic moon because it's getting internal heating from the planet Jupiter and causing volcanic eruptions, which many planetary geologists are interested in. But it's a relatively large moon, and in fact, it's just slightly bigger than our moon. In fact, this image right here just shows you roughly in size comparison of our moon, the planet Earth, and everything. Next stop, Europa, Jupiter 2. It has a little bit of a longer orbit, so one orbit's roughly about 3.6 days, and it's just slightly smaller than our moon. So the Galilean moons are pretty unique in the sense that they're just roughly about the size of our moon itself. And it's relatively cold, but what makes it so unique is that it's basically a gigantic ice ball, that it doesn't have much of a rocky surface, and astronomers are really interested in checking out this unique moon. Next up, Ganymede. Ganymede is actually slightly larger than our moon. In fact, Ganymede is considered the largest moon in our solar system, and it's roughly 1.5 times that of our moon itself. And it's basically composed of rock and ice, but thanks to the Galileo and the Cassini flyby mission, they noticed that there were some other unique features that were in Ganymede that possibly it could have liquid water. And we're hoping to send spacecraft to investigate it in the future. And last but not least, Callisto. Callisto is also slightly bigger than our moon. So even though they're like 1.4, 1.5, they're still relatively within the same size comparison to our moon. And it's mostly composed of rock and ice. So if you have a pair of binoculars or a small telescope and you were to look at the planet Jupiter, this is kind of what you would see. The bright planet in the center and these 4 little stars that will be either to the left or to the right of the planet. And those would be the Galilean moons. All right, let's take a up close and personal view of these individual moons. Io itself. Now, it's sometimes nicknamed the cheese pizza moon because to me, it kind of looks like the surface of a cheese pizza. And that's because that surface is mostly sulfur dioxide and a bunch of silicates, so hence why it gives its unique yellowish color. And it has over 150 active volcanoes, but in total 400 volcanoes, some of which are thought to be dormant. And it has over 100 mountains. Now, these mountains and volcanoes are created due to internal heating because of the gravitational tugs of Jupiter. The largest volcano on Io is roughly 200 kilometers in diameter, and it's called Loki. It's that dark gray, this dark black one down here. I call it dark gray and black because it encompasses this entire area. It's a huge volcano on Io. And here's just an example of what's happening on Jupiter that literally, or forgive me, Io, Jupiter itself is pulling Io from the inside out. That's where it's getting its internal heating. And so sometimes it will spew out volcanic ash and different types of material out into space, which then get caught up into Jupiter's magnetic field. Next up, Europa. It looks like it may have a smooth surface in several areas, but it also has icy spikes, some as tall as 15 meters. So it's not very smooth, and even though it does look smooth. So hence why astronomers are interested in landing spacecraft there, but we have to be careful of where we land it, or else we could accidentally land on all these tall spikes. It's a huge, gigantic ice ball, but the one prominent feature that you can see on the surface of Europa are these dark lines, like they kind of look brownish in color. This is due to tidal flexing because of the gravitational tugs of Jupiter on this moon. And some of the material, which is thought to have like magnesium and sulfate kind of materials, is seeping up from underneath and coming to the surface and then freezing as soon as it hits space. Also, it has lenticulae, which are like these freckles on the surface of Europa. And they basically look like these little funky dots or freckles rather than these dark lines. And that's thought to be more due material that's slowly seeping up from underneath. So could it possibly have a liquid ocean? Next up, Ganymede. It's often nicknamed the dirty ice ball because it literally looks like somebody took an ice ball and shoved a bunch of dust and ash and stuff on it and just rolled it around, and voila, there you go. About 60% of Ganymede is thought to be water ice and a bunch of dark compounds. So hence why you see this contrast of like light material and dark material. Like if you look at the crater impacts, like this one in particular right here, you can see all this white material, which is thought to be water ice. And last but not least, Callisto. It's also a dirty snowball, but they think that there's other types of subsurface material and possibly water frost deposits from different materials. And it also has fractures and scarps. So even though this moon is relatively farther away from Jupiter, it's still getting gravitational tugs and flexing. Astronomers believe that these scarps or these cracks and things are caused by both cratering and possibly cooling down over time. And of course, on the surface of Callisto is one of the largest craters of all the moons around Jupiter, and it's the Valhalla crater. It's a huge crater that encompasses the most of Callisto. All right, let's dive deeper into the moons and look at the structure. Inside Io is basically this huge iron core, but it's mostly molten from outside. So it has a huge magma deposit. And this is due to tidal heating versus radioactive decay. Now, what does that mean? Inside of our Earth, we're not getting a lot of gravitational tugs from things. We get a little bit of gravitational tugging from the sun, but not as much. What causes us to be able to have magma in our Earth's crust is due to radioactive decay and natural friction of heavier elements wanting to sink in towards the center of our planet. Whereas in this case, it's mostly tidal heating. It's basically the gravitational friction of playing tug of war with Jupiter. And so hence why it's some slightly egg-shaped. So basically Jupiter's tugging it on so much that it's distorting its shape. And even though it doesn't have a magnetic field, it is dominated by Jupiter's. So the fact that you can see certain structures on Io that look like they're magnetized is because it's so close to Jupiter that its magnetic field overpowers any types of silicate material on Io. In fact, Io loses about 1 ton per second of material out into space due to this gravitational pulling from Jupiter. And those particles that are ejected out, as you saw with the volcano eruption, is then those particles then become ionized, and it creates this ion flux tube that goes in orbit along with Io. And then some of that other material kind of spreads out into this torrid that goes around Jupiter, because in that area, the particles are so ionized and it causes strong radio emissions. And they detect that some of these plasma can create electric arcs that could be over 400,000 volts. So that's why it's very important for spacecraft that visit Jupiter not to get too close into Io, and or to find a way to avoid this plasma torus around Jupiter because of such high radiation. It's basically kind of like the Van Allen belts that exist around our planet, but just much more powerful. Next stop, Europa. It has a magnetic field which is induced by Jupiter's magnetic field. So you can induce a magnetic field if you have a powerful magnetic field next to you. And due to tidal heating and radioactive decay, we suspect that it might have a subsurface ocean with organic compounds. We're hoping to send probes to Europa in the future, but due to world events such as COVID, a lot of things got to be put on the back shelf. But there are two possibilities. Like, it could either be like a warm convecting ice and or a liquid ocean, but many astronomers believe that it could indeed be a liquid ocean. Next step, Ganymede. Now, Ganymede is the unique one that astronomers were perplexed at, that even though it's slightly about the same size as Mercury and is slightly larger than our moon, they might think it has multiple layers because of just some of the material that was spread out from due to cratering. They noticed, like, as the crater would hit, some different types of materials would come out. So could this be that it has multiple different layers, like different saltwater rock and ice and different layers like here on Earth? But we don't know. And what also interested him is that it does have a small magnetic field independent of Jupiter. So it has a molten core that is convecting, small, but still a magnetic field. So astronomers are really interested in going to Ganymede to check out the magnetic field structure, as well as maybe to do some studies to these different layers of Ganymede. And the way they also could tell that it does have a magnetic field is that along these particular lines, they've detected aurora. And last but not least, Callisto. Now, this is the one that's really odd because it has such a huge core. And it has this ice lithosphere. So rather than have a magma layer, it's mostly ice. And it possibly could have a thin ocean, but we are not sure since this moon wasn't really investigated as much as the other moons. So who has visited these moons in particular? Well, when you visit a planet, you often have to take a stop to visit the moon. And Pioneer and Terran 11 were the first ones to take images and improve estimates of masses. Because back then we were using land-based telescopes to get estimates of masses and some images. It wasn't until Pioneer 10 and 11 that we're able to get up close and personal views that are much better than many land-based telescopes. And of course, Voyagers 1 and 2 even blew those images away because they were able to get much closer into Jupiter. And last but not least, Galileo, which was the spacecraft that did a bunch of up close and personal images over a long period of time, kind of like the Cassini mission. Cassini also visited Jupiter because it used its gravitational tug to head towards Saturn, to where it was its ultimate destination. And it did a couple practice flybys around Jupiter and took a bunch of images on the fly as practice for Saturn. And that video that you saw of the volcano erupting on Io came from Cassini. And of course, New Horizons did some observations as well, especially of its magnetic field. And currently right now, Juno is taking looks at the polar regions of the moons and the volcanic plumes and a bunch of other things, especially the magnetic field structure of Jupiter itself. So here are some future missions that we're hoping that could basically look at the moons even further. JUICE, yeah, the funny thing about the different spacecraft that sometimes go to these different moons and different places in our solar system, I swear that the engineers and scientists at NASA have a heyday trying to make names for these unique structures, because it must be like alphabet soup and they just put together just something just to make it fun, because they named it JUICE, which is the Jupiter Icy Moon Explorer. So they must have fun with some of these acronyms. But basically the JUICE is going to be looking at Ganymede water. So it's going to take a look at those different layers. And the Europa Clipper is looking at the habitability and looking for a safe landing site to possibly land a rover that can have like a polar digger that can take an ice core from Europa and maybe or dig deep enough to where it can send a robotic sensor and take a look underneath the surface of the ice and check out what could be underneath there. Could it be just more ice, or could it be an actual liquid ocean, and what could be under there? And of course, that is implied with the Europa lander, where they can take ice cores and possibly do some further exploration. And then of course the Io volcano observer, which is going to look at the tidal heating exploration and like, could other different types of moons and things have the same type of tidal heating, and what does it take to have tidal heating? So currently right now, where can you see Jupiter? So if you look towards the east and the southeast, around about 8 o'clock, 9 o'clock in the evening, you should see the two bright stars in the eastern horizon. And those two bright stars are the planets Jupiter and Saturn. And of course, if you look towards Jupiter, which is closer towards the eastern horizon, and if you have a good telescope, you not only see the planet, but the 4 moons as well. So this was a brief exploration of the Galilean moons. If you have any questions or comments, leave it down in the comments below. If there's a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.